Good morning, everybody, and welcome back to another wonderful day. We are going to be talking about adding and subtracting fractions with unlike denominators. And we are going to start with a problem that reads 4/6 plus 6/12. Now, I know that I'm going to need to change one or both of these fractions in order to create fractions with like denominators. And we've learned how to do this because we've already reviewed creating fractions with like denominators using multiplication and or division in order to compare. Now, I am actually going to use multiplication because I know that 6 times 2 equals 12. So that means that I need to multiply my denominator and my numerator by 2. So that leaves me with 8/12 added to 6/12. So I've created that equivalent equation, and now I'm adding apples to apples. Now, just like we have before, if the denominator is the same, it does not change when you're adding and subtracting. 8 plus 6 is 14. Now, you're probably looking at me going, Ms. Pike, that's an improper fraction, and we know that that's not right. So we are going to take a look at how to turn this into a mixed number. And one thing that you're also going to have access to this week is my video on mixed numbers and improper fractions and how to convert them from one format to the other. So you're kind of getting a preview of it with the addition and subtraction. Now, this is more common when you're adding because adding fraction pieces is going to, a lot of the time, give you fractions that are more than one whole. So let's take a look at what this looks like as a picture. I need to draw 14/12. Well, I know that one whole has 12 pieces. So I'm going to start with one bar with 12 pieces. I know that I can split this into thirds. And 3 times 4 equals 12. So I'm just going to take these 3 pieces, split them into 4, and I will now have 12 pieces in all. And now I can start shading. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But that's 12 pieces. I have 14. That means that I'm going to need another fraction bar with 12 pieces. Split it into thirds, split each third into fourths. Now remember, when you're drawing fraction bars by hand, you're not going to get them perfect. It's okay. So that was 12, and now I have 13 and 14. So let's now take a look at what this looks like when we convert this into a mixed number. So I know that I now have one whole, so there's one whole candy bar, and I have 2 pieces out of 12 shaded on the next bar. And now if I'm remembering my greatest common factor, I can simplify this even more. So I'm going to divide the top and bottom of this by 2, which means that I am left with 1. 2 divided by 2 is 1 piece out of 12 divided by 2, 6. And if I'm grouping these into groups of 2, there's 1 group of 2, 2 groups of 2, 3 groups of 2, 4 groups of 2, 5 groups of 2, 6 groups of 2. So there's your simplified fraction. Now let's take a look at what this looks like when you actually use the proper steps to convert 14/12 into 1 1/6. So in order to do so, I need to remember that a fraction is essentially a division problem. Your numerator is your dividend, your denominator is your divisor. So I'm going to divide 14 divided by 12. And I can do this with standard algorithm or cookie thief. We're going to do both. I'm going to start with standard algorithm. My divisor goes on the outside, my dividend on the inside. 12 cannot be divided into 1, but 12 can go into 14 one time. 12 times 1 is 12. I have 2 left over. Okay. And now let's look at with cookie thief. 12 divided into 1 and 4. You can't take any cookies from the first apartment, so those cookies escape next door. He can take one set of cookies, so he steals 12. That means 2 cookies get away and run to the roof. Now, we need to make some connections here, because taking a division piece and turning it into a mixed number is where a lot of people get confused. You are going to end up with a whole number, you are going to have a numerator, and you will have a denominator. Now, I'm going to start with my whole number. Your whole number is the first piece of your quotient, which is 1. Okay? Your numerator is your remainder, and I forgot to slide my remainder up here earlier. Your numerator is your remainder, which is 2. And the denominator does not change. The denominator on your original fraction was 12. So your divisor is your denominator. And when we put all this together, we end up with 1 and 2 twelfths, which is what we ended up with at first here. And then we realized that we could simplify this even more. And we divided by 2 to equal 1 and 1/6. All right, so that's a little preview into mixed numbers and improper fractions and how converting them is going to go. I highly recommend that you watch that video before you attempt the adding and subtracting fractions assignment that you are going to be given this week, because there are a couple of addition problems that are going to give you an improper fraction. Now, I'm okay this week if you leave it as an improper fraction for the basic computation of adding and subtracting fractions. But if you'd like to push yourself, you could even list what the improper fraction was, comma, and then also give me the mixed number. That way you can show me that you've already begun working on this skill. All right, so let's take a look at our next example. All right. We have 6/7 plus 5/14. And yet again, I know that I can multiply 7 times 2 to equal 14. So that means that I can just convert the first fraction and leave the second one alone. 6 times 2 is 12, 7 times 2 is 14, and I'm going to continue adding 5/14 to it. My denominator does not change. 12 plus 5 is 17, and I'm left with 17/14. Now again, with the basic computation, you can leave this that way, or you can take it a step further. I'm going to go ahead and take it that step further. I'm going to divide 17 divided by 14. So that leaves me with a mixed number of 1 and 1/3. Or I'm sorry. Miss Pike's brain went a little crazy there for a second. Ignore that. Leaves me with a mixed number of 1 and 3/14. So even see, Miss Pike, sometimes I make mistakes and I have to go back and I have to check myself, because I have to remind myself that this portion of my quotient is my whole number, that the remainder is my numerator, and my denominator does not change. Now, I can look at this and I can say, well, the factors of 3 and 14 are 1 and 3, and then 1, 2, 7, and 14. So I cannot simplify this anymore, which means that 1 and 3/14 or 7/14 is the correct answer. All right, let's take a look at our last addition problem for this time. We are going to add 2/8 plus 3/8. Now I'm sorry, 2/8 plus 3/18. I apologize. I've got so many notes sitting next to me for this one that my brain's just crossing everything. Now, I cannot multiply 18 times anything to get to 8. I can't divide 18 by anything to get to 8. So I'm going to have to figure out a least common multiple. So my LCMs of 8 and 18. Now, if you remember when we were talking about least common multiple, usually the least common multiple is when you're going to be multiplying them together. So I'm going to multiply 18 times 8. 8 times 8 is 64. 1 times 8 is 8, plus 6 is 14. So that I can multiply 18 times 8 and 18 times 8. And whatever you do to the bottom, you must do to the top. So my new denominators are going to be 144, because the least common multiple is going to be 144. 2 times 18. I'm pretty sure I know what it is, but it never hurts to check. Yep, 36. And 3 times 8 is 24. So now I can add. I'm going to leave my denominator the same, and I need to add 36 plus 24. 6 plus 4 is 10. 3 plus 2 is 5. Plus 1 is 6. So 60. Now, the reason that I took you to such a large fraction is because I want to show you that simplifying isn't a one-time thing. You can divide multiple times and slowly take it down to the simplified fraction, and that's okay. So I'm going to show you by starting with 60 over 144. I know that I can divide both of these by 2 because they're both even numbers. Well, 60 divided by 2 is 30. 144 divided by 2. Well, I know that 140 divided by 2 is 70. 4 divided by 2 is 2, so that is 72. And I can still divide these by 2 because they're still even, so I'm going to divide them by 2 again. 30 divided by 2 is 15. 70 divided by 2 is 35. 2 divided by 2 is 1, so 35 plus 1 is 36. And now I can look at this a little more rationally. I know that 3 times 5 is 15. I know that 3 times 10 is 30. 3 times 11 is 33. And 3 times 12 is 36. So I can divide both of these by 3. 15 divided by 3 is 5. 36 divided by 3 is 12. I cannot divide 5 and 12 by the same number and get a logical answer. I just can't. So my final simplified fraction is 5/12. So see, just because maybe you figure out that a common multiple is one number, but then you get it down and you realize I can still divide that. You can divide again. Simplifying fractions is not a one-time deal. If you have a big fraction and you say, well, I know I'm just going to take the easy route. I know those are divisible by 2. So let's get it a little smaller. Well, I know those are still divisible by 2. So let's get it a little smaller. That's fine. That is perfectly fine. Do not ever feel bad for having to do it that way. Okay? All right. Well, that is the first portion on adding fractions with unlike denominators. Now we have to get to subtracting fractions with unlike denominators. This part is a little easier simply because we are not going to have to deal with that conversion piece. All right. So I have 6/9 minus 7/27. And yet again, I have to have fractions with the same denominator. I know that I can multiply 9 by 3 to get 27. So 6 times 3 is 18. 9 times 3 is 27. So then I have 18/27 minus 7/27. And now I'm subtracting apples and apples. My denominator stays the same. 18 minus 7 is 11. And I know that I cannot divide 11 or 27 by the same number and get a logical whole number. So that means that I am done. Easy, easy peasy. So let's take a look at our last example. I have 3/4 taking away 2/7. Now this one's a little more complicated because I can't multiply 4 times anything to get to 7, and I can't multiply 7 times anything to get to 4. So I'm going to have to multiply them by each other. So I'm going to multiply 4 times 7 and 3 times 7 and 7 times 4 and 2 times 4. 3 times 7 is 21. 4 times 7 is 28. 2 times 4 is 8. 7 times 4 is 28. Now I'm subtracting apples and apples. My denominator does not change. It stays 28. 21 minus 8. Think about it in our heads. And if you need to do the subtraction, that's fine. 21 minus 8. 11 minus 8 is 3. So that leaves us with 13. And now I can sit down and think, well, I know that 13 is a prime number because it only has the factors of 1 and 3. 28 has factors of 1, 2. Let's see here. 3 times 9 is 27, so not 3. 7 times 4 is 28, not 5. 6 times 4 is 24. 6 times 5 is 30, so not 6. 7 times 4 is 28. 8 times 3 is 24. 8 times 4 is 32, so not 8. Not 9, not 10, not 11, not 12. So we're already past the halfway point, so 28 is the final. I cannot divide 13 and 28 by a common factor higher than 1, so it is the simplified fraction. All right, guys, well, thank you so much for watching this morning. I appreciate it. And if you have any questions, please let me know. Have a good one.